Okay, how you guys doing, all right? So what we'll do today is we'll continue with what we did yesterday with organic chemistry. Okay, and we'll do some molecular modeling. Okay, and I'll get some kits and we can kind of put things together. Clear? Okay. And I'll film you. Is there anybody in here who cannot be photographed or filmed? Okay, and if you don't want to be, I can somehow avoid your face and we'll just look at, you know, how you're manipulating the materials. Okay, so, right, let's look at where we left off yesterday. Now, what is an alkane, an alkene, an alkyne? What is that? Remember?
Bond between say, carbon and hydrogen.
Okay, this is just simply, these are all carbon-hydrogen, hydrocarbon chains, okay? Where you have all single bonds, you have an alkane, okay? And we have one carbon is methane, two carbons is ethane. Help me out here, guys. So talk to me. Propane, butane, pentane, hexane, heptane, octane, nonane, and decane. And you got to memorize all that stuff. Organic chemistry is a tremendous amount to actually memorize. It's a language. It's like having a vocabulary. And the more work you do on it, the more you read, the more problems you do, you will memorize it just by doing the work. Yes? If I tell you, let's see if you've already memorized something. What functional group is that? What functional group is that? Alcohol. So you've already memorized something, right? Yes? 1, 2, 3, 4 carbons. What is the name of that? And that alkane? Butane. That's right. Yes? Do you see that? Okay. Now, so what is the difference between alkane, alkene, alkyne? We'll make this like this. And then we'll do another one for an alkyne. So what's the difference? What do I have to do to the alkene and the alkyne to make them an alkene and alkyne?
Some of the carbon bond in alkane have double bond.
Double bond. I need a double bond here. Yes? So I've got to get rid of a hydrogen. Yes? 1, 2, 3, 4. 1, 2, 3, 4. Correct? Every carbon has to have 4 bonds, right? And what do I do to this? I have to put in a triple bond. There we go. Okay? Now, let's look at these two bonds, these bonds. Okay? Let's look at this right here. Okay? Let's look at those 3 bonds. This carbon bond, this carbon bond, and that carbon bond. That relationship, okay? This is what we call sp3, sp2, and sp. Yes, do you remember that? You remember hearing it. You may not remember it, but what it is. But do you remember ever hearing about sp hybridization? No? Okay, it's in your book, it's in the bonding chapter, that's okay. But it's very important that we go over that. Okay? Now, you know S and P orbital structure, correct?
Yes.
You remember that? Okay. So we have a carbon. 1s and then 2s, sorry, 1s, 2s. You know what, let me erase this. Let me erase this. We'll go down here, and we'll say this is carbon, and this is the orbital structure. Okay, 1s, 2, 2s2, 2p2. Correct? Yes? So this is going to be 2 electrons in that orbital, and then 2 electrons in this orbital, and then 2 electrons in this orbital. Right? Now this is the valence shell, correct? That's where the bonding is going to take place. Yes? Let's look at the Bohr model, okay? We know we have the nucleus, and then you have, this is the first shell, we have 2 electrons, and there's the second shell, this has 4 electrons. Right? Correct? Yes? So we need how many electrons in the valence shell for it to become stable like the nearest noble gas?
8.
It needs 8. Okay, good. So it will have a total of how many electrons? 10, like neon. Okay, good. So where am I going to put those electrons? Do you see that this is certainly not going to work? Is it? It's not going to work. Right? Is it? Because I can only have 2 bonds here. You see that? The way this is set up? So carbon has to do something in order to make this happen. And what it does is this. It's really bizarre. It's life. It's amazing. Okay? It says, right, let's do this. We'll do sp3 first, because that's the one that everybody thinks of when you think of hybridization. It's kind of the easiest one to understand. What happens is this. This level undergoes this change. Do you see how that this electron, this orbital, is at a lower energy state? Okay, energy is increasing, going up. All right. So I drew this on the board purposely like this. So 1s is low, 2s is a little higher, 2p is higher. You see that? Well, what happens is this. Can I erase the Bohr model of the atom here, please? Yes. What happens is this, that these 4 orbitals become the same energy, kind of an intermediate energy. So they kind of go like this. Okay? And I put 1 electron in each one. Okay? So I can form 4 bonds, 4 equivalent bonds, can't I? Yes? Those bonds are called sigma bonds. They're called sigma bonds. Okay? And those bonds, they look like this. If I take a sphere, right? Let's do it this way. Let's take, well, they broke these today. Those different sizes. Isn't that cool? All right, so let's do that. Let's go to, let's get the different sizes here. We'll get different size thingamadoohickeys here. Okay. All right. These are going to be hydrogen atoms, for instance. Ooh. Ooh. That's really hard. I gotta somehow get this in here. Can't do that. There we go. That's going to be the hole maker. Okay. All right. Now we have it. Okay. All right. Now we need one more. We need a hole maker here. shapes. Okay. All right. So these are hydrogen bonds. Ooh, that's really, I tell you, that's really tough. Now this, we're going to say, is the carbon. Okay, that's the carbon. Now, these are going to be like, these are going to be bonds, and they kind of look like this. They kind of look like this. Here's the carbon, right? So we'll say that's the carbon. So you have these four spheres, these four things here, and what they do is you have hydrogen. We'll say this. We'll say this is hydrogen, right? Right? And they kind of like bond like that, right? Right? There's these electrons in there. Right? Here's hydrogen. Right? And then hydrogen here. Right? Yeah, get it? Easy? And in the center here is carbon. Right? Looks like a nice little flower. I think I just drew on my lip. Okay. It's okay. It makes me look better. Okay. Nothing like putting a little red lipstick on in the morning to make you feel like you're alive, you know? Okay. So they look like this, okay? They come at angles of about 109.5, okay? Kind of looks like this. Does anybody know what the shape is? Do you guys do this, geometric shapes and all that stuff? Yeah? You have to know them all. You know what the T shape is? You know how to do it? T shape and all that stuff? You do? Okay. All right. What shape is that?
Tetrahedral.
That's a tetrahedral shape. That's right. That's what that is. That's a tetrahedral shape. Yeah? And that's from sp3 hybridization. Now, you could put, if I put 4 hydrogens on there, that's called methane. Correct? Yes? And if you kind of look at it, you have this funky way of looking at it, you know? These are all kind of like individual tetrahedrons that form. You know? These bonds all form at 109.5 degrees. Yes? So they all go out in chains, and if you look at them, if you look at one carbon, isolate one carbon, like for instance, this could be, let's say that this is going to be, this is a carbon. Let's say this is a carbon and this is a carbon, right? Right? Let's just say, let's pretend. Okay. So what happens is that they go like this. You see that? You see that? Kind of goes like that. So what happens is this. This is what the alkane looks like. Can I get rid of this? Is that okay? So this is what it looks like, and you'll see this when you make this. Okay, if you look at the bond angles when you do this yourself. Look at this. Kind of looks like this. See that? So if I put these together in chains, let's say these two are carbon. Okay, these two are carbon. Do you see how it's going to go down like that? And it's going to go up like that, then down, then up, then down, then up, and so on. These long chains, right? And then you're going to have these hydrogens up here, and then you're going to have them down here as well, right? So you're going to have up, down, right? Like these little, if you look at it like this, they look like little ears, little rabbit ears, right? Now that's sp3 hybridization with 3 sigma bonds. A sigma bond is a bond that is a result of the hybridization. So if you have an sp orbital, we call it sp orbital. We don't call it an s orbital. We don't call it a p orbital. We call it an sp3 orbital. So it's an sp type orbital. You get it? It's some kind of sp. It's special. sp. Special energy, special orbital, special mechanics, special geometry. Everything is special about it. It's sp. Clear? Okay. So now what happens when you form an alkene? An alkene. You have a double bond here. It's a little weird, isn't it? You You have a double bond. What's that double bond for? How do you get a double bond with this kind of hybridization that I showed you? Okay? So what happens is this now. This is what happens. You ready? So what happens is, let's just look, can we just look at the 2s, 2p? Can we forget the 1s? Is that okay? That's not important. We're looking at the valence electrons, just the second level, okay? Yes? Okay. So we're going to look at, this is going to be 2s, right? And then 2p, right? Correct? That's the non-hybridized form, correct? Yes? Well, what happens is this. This is going to be, I'll draw sp2 up here and sp down here. So you have two types of hybridization. And I'll draw, can I get rid of, no, I'll draw it over here. We have, this is going to be 2s, and this will be 2p, right? That's what it looks like before hybridization. And here, I'll draw the non-hybridized form, okay? The hybridized form. Okay, this is going to be sp2 and sp, okay? Yes? Yes? Okay, so what happens is this. I form this. So this is sp2. So there's three special sp orbitals, right? There's three special sp orbitals. We call sp2, just the name, right? And then we have one left over, okay? And then down here, sp is going to be, we're going to have 2 down here, and then we're going to have up here. So we have sp, s, and 1p. You get it? Okay? And then we're going to have these old guys. Okay, so these are these. Okay? Let's make these blue. So these, that's blue. That's the old guy. I think these two are the old guys. Okay? Okay? You get it? So what happens is you still get this, right? So you're going to have like this. Okay? You're still going to get that. Yes, that redistribution of the electrons. But you're going to, instead of forming 4 orbitals all the same, like with this tetrahedron, you're only going to form 2 here, 3 here, and 2 here. Okay? So then what happens is this. What happens is this. This is easier to draw, this one. This one, you're going to have to use a little bit of your imagination, and we'll do the orbitals here. Okay. This one looks like this. Here's the carbon. Here's carbon. Okay. I'm going to make 2 carbons that are both sp2, 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 sp3, sp3, sp2, sp2. Okay. All right. So you get this. Right? That's a sigma bond, right? Sigma, 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 pi. Right? That's what they call a pi, p for pi. And then you get another one over here. Another one over here. This is going to go to a hydrogen. No. Yeah, this one's going to go to another carbon. Okay. Carbon. Okay. And then you have this going to another hydrogen. Right? and then this going to another carbon, right? Because you only have 2 hydrogens, right? 1, 2. You see that? You have 2 hydrogens. So that's to a hydrogen, that's to a hydrogen, that's to another carbon. That's to another carbon. Now, what's missing here? What's missing? What's missing? I should have done it in red because those are sigma bonds, but whatever. I'm just going to reverse the colors here. Sorry. Okay, I'm going to reverse the colors. So you get this sigma bond, a pi bond that looks like this. You know what a p subshell looks like? Looks like this. That's what the p looks like. You have 3 of them, right? 3, you know, normally on the different axes. Okay, it goes like this. Okay, and you get this overlapping here. Okay, you get it? Yes? Shorter bond, longer bond, stronger bond, weaker bond. Pi bonds are shorter and they're weaker. Yes? Now you can see what's going to happen here with this one. You're going to have 1 sigma bond. You're going to have 2 sigma bonds, right? Correct?
Yes.
For each carbon, right? So it's going to look like this. It's going to look like this. You're going to have the carbon, sigma bond, right? And then you're going to have another sigma bond to another carbon. Right? Because you don't have any hydrogens off there, right? So this is a sigma bond. That's a sigma bond. That's a sigma bond. Right? Yes? You get it? So this is going to a carbon, this is going to a carbon, this is attaching to 2 carbons. Now we have 2 pi bonds. So you're going to have, you can make it like this. You have kind of like this. Let's put it at an angle maybe. And then you have this. Then you have this. The ones at angles overlap. And then these overlap. Right? Kind of looks funky, yeah. So you have 1, 2, 3 bonds, right? So it kind of looks like this. Let's see if we can do this. No, you know what? Let me see you try to do it. Okay? I'll have you try to do it. Yes? We'll do that. And let's look at, let's do some more, just a little bit more on functional groups, etc. But I had to get that out of the way. Maybe we'll do that as like an actual lab. We're actually going to do a lab in here, the next class. But I had to get that out of the way. You never did anything like that? No? Okay, I'll show you where it is in your text, but that's pretty important stuff. So let's quit there, and then I'll come back and make another one, so it's not overwhelming. Okay, so you don't have to watch a zillion hours to get a point. Okay, and we'll call this alkenes, alkanes, alkynes, and hybridization. Good, good. Okay.